Thank you. Good afternoon or good morning, depending on which time zone you're in. I will be talking about career opportunities in the energy industry. I hope to have my comments last about 35-40 minutes, and then we'll have time for questions and answers. A brief outline, a little bit about myself, how I got to where I am, a little bit about what we do in the energy industry. G&G is my code for geology and geophysics. I'll give you my outlook for the energy industry careers. We'll talk about 3 big positive factors and 2 major concerns, and then how you can prepare for a career in industry. And as I mentioned, we'll have time for questions and answers. A little bit about myself. I got a engineering physics bachelor's at Lehigh University. Then I went to Columbia University, Lamont Doherty for a master's PhD. I was with Exxon, then ExxonMobil Research for 32 years. I've been a visiting lecturer at Texas A&M, and most recently I have 3.5 years now with Noble Energy. When I came out of grad school, I was triply blessed. Industry was just starting a hiring boom. I received an offer to work at Exxon's research center in Houston, and I was assigned to the seismic stratigraphy section, which was cutting edge at the time, and I was mentored by Pete Vail and Bob Mitchum, who most people would attribute to being the fathers of seismic stratigraphy. My specialties are in research and development of new methods associated with seismic interpretation and analysis, apply those methods, and I do a lot of training and a lot of mentoring. What we do in the energy industry, this slide breaks it into 4 main components: exploration, production, refining, and marketing. We talk about exploration and production as being the upstream. That's where we find the oil and gas, get it out of the ground, and ship it off to the refinery. And then the downstream is the refinery and the marketing. There's a challenge for the upstream. This is a chart showing energy demand in million barrels oil equivalent per day. From 1990 to projected out to 2040, and so 2015 is right about in the middle. You can see that the energy demand is going to continue to increase, and in 2040 we anticipate about 50% more energy need than current. Using the same years, this shows production. The left half of the diagram shows existing production, and then the right is a projection out to 2040. If we just produced the fields that are currently on stream, we didn't add any new fields, we didn't add any new compartments, we just drained what we already are draining, you can see that the green line goes down almost to 0. And so there's a big gap between energy demands and what current production would provide. So that orange wedge on the right is our challenge. How do we come up with the energy that people around the world are going to need? We'll come up with that energy by making new discoveries, by taking static reserves that are in the ground but are not economic, and somehow being able to produce them at a profit. And probable is fields that we've had a discovery, but we haven't had enough confirmation that there's enough there to be economic to move it along into a production mode. So what we need is we need to drill good wells, ones that have low risk, and maximize the returns on our investments. Wells can be very expensive, some over $200 million, and so we must position each well with care. We need as accurate as possible an understanding of the subsurface so that before we drill the well, we know what we're going to encounter, and therefore we can maximize oil and gas recovery from our known fields. We can move probable and static assets to the proven reserve category. We can discover new reserves beneath known fields or adjacent to known fields, and we can find and produce oil and gas in totally new areas. So the energy industry needs geoscientists with the talent and the drive to find and then develop and then produce the energy that people will need. What do we need for success? Let me show you a very oversimplified example. First, we need a kitchen, a place where organic material is cooked. Then we need in the subsurface a container, a place where we can extract the oil and gas. The kitchen and the container are usually separated in geological time and in aerial position, and so we need plumbing to hook up the kitchen to the container. Then we have to put the well in the right location, and oil comes out of the ground and money goes into the bank. Unfortunately, it's not quite that simple. What we need in a more technical sense is we need a source rock that's going to generate hydrocarbon for us. We need hydrocarbon migration pathways so that the oil and gas molecules can get to a place where we can produce it from the subsurface. And then for the container, we need a reservoir quality rock, we need a trap, and we need a seal. And I might interject that this is for conventional reserves. Unconventional reserves or resource plays don't quite fit this simple model. Let me show you an example. This is from the Norwegian side of the North Sea. We'll talk a little bit about the hydrocarbon system here, the source reservoir, trap, seal, and migration. The oldest deposits that we're interested in are called the Brent sandstones, and that will be our reservoir rock, and it will also be our hydrocarbon pathway. On top of that was deposited the Heather Shale and the Sonefjord Shale. Both of these are organic poor, so they're not adequate as a source rock. On top of this was deposited the Draupne Shale. In the English side of the North Sea, it's called the Kimmeridge Clay. It's a very organic rich rock, and that serves as the main source rock for all of the production in the North Sea. We can model, given the burial history and the heat flow history for the area, we can model hydrocarbon generation and expulsion. We'll get some gas generated from coals out of the Brent, and we'll get oil and gas out of the Draupne or Kimmeridge shales. We can model how the hydrocarbons will migrate out of the source towards the reservoirs, making use of stratal components and also go up the fault zones. And then we can consider the volume that has been generated relative to the volumes of the traps. And in this case, the deepest trap here originally filled with oil and gas, but the excess gas that was produced has flushed all the oil out. The oil has gone up the fault and has excuse me, filled some traps, not in the deepest structure, but midway up the basin. So let's look at my outlook for careers in industry. The main question that people will have is this a good time to start a career in the energy industry, one that will last 30 plus years? And long term, I think the timing is good or even great. However, there is some short-term effects that are in play that may make the timing right now in 2015 a little bit on the poor side. Energy industry goes through cycles in terms of oil and gas prices. These cycles last about 7 to 10 years. This is, I think, the 5th downturn in oil and gas prices I've seen in my 37 years in industry. These cycles dictate the price that we get for oil and gas, and I think it's no surprise to anybody in the audience that oil prices have dropped quite a bit. Right now, prices are low. We're about 50% the value for a barrel of oil as about a year and a half ago, and most, or I should say all companies are tightening their belts to some degree. So I think in 2015, we'll see a reduced number of job openings and a reduced number of summer internships. Prices will rebound, and when they do, the demand for new hires will spike. So we have to wait for the sun to come out from behind that black cloud of low oil prices. Let's look at three positive factors in terms of a career in industry. The first is energy demands, the second is technology needs, and the third is the energy industry demographics. So we've already touched on these two graphs. The demand for energy is going to continue to increase, and if we don't do anything but produce from our known fields, we're not going to be able to meet that demand. So there is a real need for us to find new fields or get new reserves that we can produce. This is a bit of a dated slide. It's from 1997. It's the only one I could find that extends out beyond about 2030. This shows the source of energy, the types of energy sources that are supposed to be utilized into the future. And you can see that the oil, natural gas, and coal, our fossil fuels, are going to be the main contributor to our energy supply for the foreseeable future. So if someone were to start a career this year and had a 35 or 40-year career, they would still be working when the fossil fuels are going to be of high importance. Technology needs is the second positive factor. To meet our energy demands, we can't simply count on making giant new discoveries. We've drilled the easy stuff. We've drilled all the huge structures, and so it's going to take a bit more effort and a bit more science to be successful into the future. We will make some new large discoveries, but we have to get more oil and gas out of what we've already found. So we'll have to get new life into old fields or make uneconomic reserves economic. An example of that is the unconventional plays. We knew for decades about oil in shale and gas in tight sands, and it hasn't been until about the last 10 or 12 years that we have the technology that those resources can be produced and used to fuel people's energy needs. So we're going to need technology. We're going to need the people that can develop that technology. We're also going to need people that can apply that technology in order to have success in the future. The third factor is the industry demographics. This is a chart showing the age of our geoscience workforce. And the big thing to note is the big spike in the people who are 50 or older. The people that are 60 plus, many of my colleagues have retired, and so they're no longer in the workforce. And as the years tick off, more and more people in the 55 plus bracket are going to retire. Those columns are going to get smaller, and so we're going to have a big need to increase the people in our workforce by hiring people with geoscience training. This is a chart that was put together by Eric Griggs for the American Geoscience Institute. He did a forecast out to the year 2021. He estimated that there's 260,000 geoscience jobs today. That's geoscience in general, not just in the oil and gas industry. The expectation is that about half of those will retire by the year 2021. If we look at the growth in the job market for geoscientists, BLS is the Bureau of Labor Statistics. They estimate an additional 72,000 jobs for geoscientists. If we look at how many are expected to graduate with a master's or a PhD, the estimate is 15,000. If we include people with a bachelor's with the master's and the PhDs, that's 45,000. So if you look at the present jobs, we add the job growth, we subtract those that are retiring, there's a net deficit of 150,000 geoscientists by the year 2021. So that certainly is a positive indicator that geoscience is a great place to be studying and preparing for a career. So we looked at three positive things. There are two negative things. The first is the recent drop in oil prices. I put the chart together, or I grabbed the chart on the right in December of 2014 when oil was about $66 a barrel. Last I checked, it's down about $45 a barrel, so it's fallen even more. So oil prices have dropped about 50% from the peak of about a year and a half ago. And the other concern is that there are a lot of students studying geosciences. This is a photo from an AAPG SCG Student Expo. I'm not sure if it was from the 2014 Houston Expo or not. But I attended that expo, and it was amazing to see how many students were there trying to get an interview with one of the oil companies that were recruiting at that event. Let's talk a little bit about oil prices and give some history about that. The chart on the left is oil production in million barrels of oil per day from 1920 to 1970. And you can see that the production was increasing. In the lower right is the price of oil in nominal dollars and also real dollars being adjusted to 2014, taking out the effect of inflation. And you can see that the oil prices were fairly stabilized. U.S. production was able to meet the rise in demand, and a simple way to say it is our U.S. wells did not have the spigots all the way open. So as demand rose, we would just open the spigots some more because we had enough reserves in the U.S. to meet that demand. In the early 1970s, that changed because our U.S. production was at 100%. And more recently, 1970 to 2014, U.S. demand exceeded U.S. production. Our spigots were open 100%, and that meant we had to import oil to meet our energy needs. The photograph is from probably 1973 or so. That's when there was an oil embargo, and there's probably not too many listening to me that remember that, but I remember being in line for about an hour on odd or even days trying to get a tank full of gas. So now world economic and political events tend to drive our oil prices. The things that impact oil prices is the concern about supply disruptions every time there's a problem in the Middle East. It's related to the production quotas that the international suppliers establish. It also is dependent on world financial instabilities, and more recently it's been impacted by the vast amount of production that we're getting from unconventional reservoirs. So here's the oil price from 1970 to 1988. You can see that at early 70s it was fairly flat at about $20 a barrel, and then it spiked a couple of times, and those two big spikes are related to unrest in the Middle East and a fear that the energy supplies, the oil coming from the Middle East, might be disrupted. OPEC, the oil-producing nations, they also can control prices by setting how much production they're going to allow to happen. So in the first part of the graph, OPEC production was at 30 million barrels per day. And then in 1978, roughly, they cut that in half down to 15 million barrels per day. So they cut the supply, and that caused some prices to drop, especially the sharp drop over here. Then in about 84, they increased the amount of production once again. From 88 to 2014, again, there were concerns about supply disruptions. Production quotas caused some oscillation in the oil prices. We had some instability around the world in terms of financial markets. And then most recently, we've had a big increase in the amount of oil that we're producing from shales and other unconventional reservoirs. That has led to a slight excess in production right now in terms of balancing the demand, and that has been one of the primary reasons for the drop in oil prices. So significant production from the unconventionals, from oil shales, has added to our supply. OPEC has not reduced its production as they traditionally would have in order to try to keep the prices stable. We currently have a slight oversupply. We're producing more each day than we're consuming, and this has caused the oil prices to drop about 50%. Some wells are being shut in, especially in unconventional fields, and as wells are shut in, that's going to cut back on the production, and so it's a matter of time for some stability to come back in where the supply and demand balance out and the prices stabilize. One of the big questions is how long will it be until the prices stabilize, and at what level will the prices stabilize? So for geology and geophysics students, long term, we will need a lot of geoscience professionals to replace those who are retiring and to accommodate the predicted growth in geoscience jobs. In a more short-term view, many that are graduating at this time in 2015 are going to find that companies are trying to cut their expenses, and therefore they are not hiring as many and are not having as many internship positions. If you're starting a career during the next 12 months, it will be challenging. Companies can afford to be very selective because there are more people applying for jobs than there are available jobs. If you have great qualifications and you put in a lot of effort to land a job, I think you still can have success. Once the oil prices rise and stabilize, I think hiring will start to pick up and actually spike because of people in industry retiring and because of the slowdown in new hires for the period that the prices are low and unstable. So thinking long term, this is an excellent time to be working towards a geoscience degree. Recruiting activity will dip for a while, but then it will rise, and I think it will rise sharply. Once the prices rebound and stabilize, the demand for geoscientists will greatly outstep the supply. So if you are analytically thinking, you have some bright ideas, you'll find the timing will be great and the pay will be quite good as well. We can look at the salaries. This is data from AAPG. They publish this each spring in the Explorer. I suspect a salary survey will be out next month or 6 weeks. And this shows from 2002 to 2013 the salaries for people in industry with 0 to 2 years of experience. So that's as fine of a subdivision that AAPG does with their salaries. If we look at salaries by your educational level, people with a bachelor's are about $90,000 a year. People that have a master's, about $100,000 a year, and a PhD, about $112,000 a year. And I'm quoting slightly lower because that's about the starting salaries as opposed to people with 1 or 2 years added into the numbers that are on the chart. I often get questions, which degree should I get? If you get a bachelor's of science or a bachelor's of art, most of the bigger companies would be interested in you in a geotechnical support position. If you work for a smaller size company, then you might actually work in the trenches along with everyone else. People with masters, that forms the bulk of people in industry, and you can hold any position within industry that you would like with a master's, with the one exception: if you want to do research at one of the large energy companies, you probably wouldn't be able to start in research. That is usually reserved for people with PhDs, but after you have 3 or 5 or 7 years of experience and you really want to do research, I don't see that being a big hurdle. For the PhD, some companies will think a person that has a PhD is overqualified for a lot of the work that they are looking to have people do, and so some companies don't interview PhD candidates. Mid-size and large-size and mega-size companies will be interested in PhD candidates as well. It is advisable, if you do want to do applied research for a mega company, to have a PhD. If you anticipate after working in industry for a while you may want to go back to academia, become a professor, then having a PhD is quite important. And if you remember the chart with the salaries, there is a bit of an increase in starting salaries for PhDs, but you also have to remember that they took 2 or 3 years more beyond the master's to get the PhD. Meanwhile, somebody that started with a master's at a slightly lower starting salary would have 2 or 3 years experience when the person with the PhD is just starting out. How can you prepare for a job in industry? This is pretty much the same for any type of professional job. You want to excel in all of your courses and get a high grade point average. Take fundamental classical geoscience courses. Get exposure to all the disciplines. Scan professional society journals and take note who's working on topics that are of interest to you. Decide as soon as you can on a subdiscipline. And if you have to do a senior topic, choose something that you have a lot of interest in, a passion for, and work it well, and use that as a means to demonstrate your scientific capabilities. For grad level students, choose a high caliber university that has a great geoscience department. Try to excel in all of your courses, get a high GPA, take courses that will give you both depth in the area you specialize, but also breadth, so that you're not so specialized that you wouldn't be as useful, especially to a mid-size or smaller company. Look for ways to demonstrate your leadership potential. Get some good work experience if you can. Internships are great, but they are hard to come by. In choosing your thesis topic, choose something, again, that you have a passion for. It's better, in my estimation, to do a superb job on a topic that might not be directly related to the oil industry than to do a mediocre thesis on something that you think would be of more interest to industry. Polish up your resume, and you do have to sell yourself. And if there are companies coming on campus, even if you're not interested in a particular company, interview with them so that you gain experience. And then when you interview for the company you really want to work for, you won't fall into some of the traps that first time interviewing tends to lead to. This is a list. I won't read through it, but there are some advantages and disadvantages for big companies, advantages and disadvantages for some of the smaller companies. And so it really depends on a person's likes and dislikes as to whether they would do best in a small, a mid-size, a large, or super large company in which to at least start their career. The other things that you should look for when you are looking at companies, of course, everyone wants to know about salary and vacation, and do you have flexible work hours or not. The location is going to be important. You also want to try to meet some of the people that you would be working with and visit the facilities. Usually for master's and PhD candidates, companies will fly you to their home base and let you get to meet the people and see what types of facilities they have. Look into the types of training that the company provides. What type of benefits do they offer? Some companies still have pension plans. Look at the job and work environments. Think about how stable that company has been as we've gone through the different price cycles. The bigger the company, typically the bigger the bureaucracy, and some people do okay with a lot of bureaucracy, other people hate it. It's fair game to ask a company that's looking at you seriously what sort of initial assignments you would be working on. And also consider for that particular company what sort of opportunities would you have to grow technically and professionally, and to move around within the company to get exposed to different types of work. So that's my prepared remarks, and we should have plenty of time to handle some questions from the audience.
Great. Thank you so much, Fred. And as you suspected, there are quite a few questions, so I'm going to try to put some of them together.
Okay.
Matt Lancaster asks, what is the best way to network with energy industry people in Colorado and elsewhere if he would ultimately like a position in the industry? Especially, and I'm trying to combine this with another question, especially if you're not at a specific recruiting school, a place that recruiters often go, how would you suggest is the best way to interact with industry people?
Yes, well, I think what I would recommend is that you do some internet searches, find companies that are in the part of the country where you would like to live and work, or that are operating in the parts of the country that you're interested in. Most companies these days have some location on their website where you can fill out an application. You don't want to do that when you're in your freshman or sophomore year, but if you're a junior, senior, or in a master's or a PhD program, it doesn't hurt to apply online, and a lot of times they handle full-time employment and also internships through the online application. So get your name in their system as soon as you can. There are different job fairs that industry sponsors. AAPG and SEG sponsor 4 of them. One is in Houston, one is in Laramie, Wyoming, another one is in California. Those three are in the fall, September, October timeframe. And then there's one in University of Oklahoma in the spring. And that's a great place where students can present a poster, and typically there'll be a number of oil companies that will send recruiters there to talk to students, to view their posters, and to have on-site interviews. So if you are not at a school where industry tends to send recruiters, then look for opportunities where you can go to a meeting and talk to some of the recruiters. You can also go to some of the professional society conventions. Again, AAPG and SEG come to mind, but they usually have student sections where you can meet with people in industry and have on-site interviews.
Great, thanks, Fred. We have a question from Mark Brown. I think it kind of relates to the question you just answered, but is it possible to obtain a full-time position without an internship?
Yes, it is. Even when prices were high and hiring and internships were available, there are usually in a given year more new positions than there were internships the previous summer. And so a lot of times people that did not have an internship will get offered a new job position. There's a lot of people that will intern at one company, but then they'll start working for a different company. So having an internship on your resume is certainly a plus, but not having it is not a insurmountable barrier.
Great, thank you. We also actually have a lot of international students on the call.
Okay.
Do you have any particular suggestions for international students? You know, whether they're studying geoscience in the US or elsewhere, is there anything particular that they should be doing differently or similarly as US students to get into the energy industry?
A lot of companies, when talking to an international student, the first thing they will ask is about the student's ability to stay and work in the United States. And I don't know all the right classifications, but if you are, I think, a permanent resident and you're able to work in the United States, you would certainly want to have that dominant on your resume. There are companies that will work with international students to go through the process of getting them right to work in the United States, but normally the supply of students who can work in the United States is more than enough for the jobs that are available, and so a lot of companies don't want to go through the time and the expense and the legal formalities trying to work with a student to get them the ability to stay in the U.S. and to work.
Great, thanks, Fred. Sorry, I'm going to butcher this name, but Luan Gwen asks, I'm finishing my master's in geophysics and planning to go for a PhD. And I think you touched on this a bit, but what specialty is most demanded by the industry? Would you say it's better to go for skills that apply to development, like seismic and petrophysics, than skills that are used for exploration, like solid earth geophysics and tectonics?
Again, I would say the best thing to do is to study something that you really have a passion for, that you're going to enjoy doing, and you're going to do an exceptional dissertation project on. I tell a story about a lady that I used to work with at Exxon. Her dissertation was on geophysics done on Mars. And the last time I checked, ExxonMobil didn't have any acreage on Mars to do exploration or development. Uh, when I went out as a recruiter for ExxonMobil, the marching orders were find us world-class scientists. And so I think it's true for a lot of companies. They are trying to decide how good of a scientist you are, and it's secondary whether you've worked on something that is directly related to a problem that they're trying to solve in the immediate future. In the immediate future. Um, so if you have a passion for something that oil companies would be interested in, that's great. If your passion lies somewhere else, um, I would I would still go after that which I had the most energy and interest in, um, so that I could demonstrate that I am a scientist that is worthy of consideration by any company, whether it's oil and gas or environmental or government agency or academia.
Great, thanks, Fred. So, to mix it up a little bit from all of the job questions, Eric Zong has a question about the future challenge of the oil industry. And he writes, because new reserves are the primary source of future revenue, E&P companies spend a lot of time and effort in finding new petroleum reserves. Since one, a new discovery, including unconventional, will become increasingly difficult, and two, recovery rate of unconventional is only about 10%, will this exploration-oriented paradigm be changed in the future?
That's a good question. I I don't think it's going to change all that much, and I said we found all the easy stuff, uh, and let me go back to that for a minute. Um, if you looked at this type of seismic data that I was working with when I started in industry in the late 70s, and compared it to the type of data we get now from seismic, it's like night and day. And so whether you were working in the 40s or the 60s or the 80s or 2000, we are always at the cutting edge of what our data will allow us to see. Um, and so what we would say our predecessors found, oh, it was so easy. It wasn't easy for them given the tools and the methods that they had. Um, so I think we always are challenged. How are we going to find new reserves, no matter what decade that we're talking about? And I think that's going to be true in the decades to come. It's going to be difficult to keep replacing the reserves and adding 1.5% each year to account for the growth in the energy demands. Um, Certainly, if we can improve recovery efficiency, that would have a major breakthrough. I'm not sure if that's something that our geoscience community is going to solve, or if that's more in the petroleum engineering arena, where increasing that recovery efficiency might come from.
Great, thanks. So specifically for people who are about to graduate, and I know that you certainly touched a lot about that on your talk, do you think it's practical then for them to, try to go to something else like academia or government or something for 5 to 7 years, while waiting for the oil price to turn around? And especially what you talked about for the internships, that a lot of people are cutting down on their internships. Um,
Yes.
and what would you suggest for students who are about to graduate, and they're thinking about the oil industry? I mean, given that there aren't a lot of internships, would you suggest that maybe they go somewhere else for a bit and try to come back when the oil prices turn around? Or what would your words of advice be for those people who may be like, oh, I'm about to graduate and I'd really like to
Right.
go into industry
Right.
now?
Yeah, yeah. I can hear people saying, why did it have to happen the year I'm going to graduate?
Right, of course.
Uh, 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 it is going to be a challenge to find jobs. There still will be some available, but it will be quite limited. And so the vast majority of people that are finishing this year or early in 2016 may have to think of employment outside of the energy sector for a while. And certainly having a, if I can say the word filler uh, uh, position that allowed you to use geoscience would be better than getting a filler position where you're selling used cars or doing something that's not related to earth science. Um, whether that's in environmental, whether it's in a government agency, whether it's in academia, um, it's really going to put some emphasis on the individual to try to think outside the box. What could I do? And I don't think it's going to be 3 to 5 to 7 years. It's probably a year and a half, maybe 2 years. Different people quote different numbers. Some people say 6 months, some people say a year, some people say 2, some people say 3. I would say about 18 months we should be through this and things should be on track once again. I wish I had an easier way to advise people what to do in the interim, but it is a difficult problem and one that I I would not relish for myself or for my children to have to be going through.
Right. Um, what about people who maybe be majoring in geochemistry? Do you think they'll have an easier or more difficult time compared with people with geophysics majors?
I don't think it would be very much different. Uh, there are more people with geophysics specialties in industry than with geochemistry, and so the number of geochemists in industry is a certain number. A number with geophysics is a larger number. I think there's more students studying geophysics than studying geochemistry, but most companies have really cut back all of their hiring targets, and so a company that might have hired 10 geophysicists may be hiring 2. A company that might have been hiring 3 geochemists might be hiring 1. So I don't think the cutbacks are favoring some branches of our science and being more strict, less kind to other branches.
Great, thanks. And also going back, Derek Goff has a question about the areas of the company of exploration versus production. And what have you seen is in higher demand right now? Do you feel like most companies are hiring in exploration or production?
I would think over the years I've been in industry, the number of people in development and production has taken more and more of the pie. Right now, companies still have a lot of need for geoscientists that are focused more on exploration. They also have needs for people that are in field development geoscience, and then also in production geoscience. So again, I think it depends on a person's individual likes and dislikes. Some people that I know love exploration and they would detest working in production. Other people that work in production would detest having to work in exploration. Many of the companies, when a person starts, they'll rotate them through 3 or 4 different assignments, each assignment being 6 to 12 months. And they'll purposely have them rotate through an exploration task and a development task and a production task. And that way the new hire who may not have a full understanding of what geoscientists do in those different parts of industry, would then have some experience, and then could decide, well, I really like production geoscience. That's where I'd like to focus my career.
Great, thanks, Fred. So there's another question from Matt Lancaster asking, assuming the energy industry is concerned about its workforce, why then has it overproduced? I'm guessing that's
It's
related.
concerned. It's concerned about the workforce. Why is it?
Why did it overproduce? I guess with production, like the actual production that we're
Oh,
talking about.
oh, yeah. With the unconventional oil shale, um, technology has allowed us to make areas, fields economic that in the past were not possible. Since each company is trying to make as good a profit as it can, with the development of the unconventional resources, each company has entered into that as much as they could, and so it would be against the antitrust laws for companies to pool together and say, well, we're going to put a certain target on how much unconventional oil we're going to produce this year. So since everyone's trying to produce what they can at a profit, the only way that production stays in check is by the demand side of the supply-demand chain. So since we are overproducing the last couple of months, prices have dropped, and then that causes the profitability of some of the unconventional resources to go negative, and so those fields will be shut down, those wells will stop pumping, and that will cut back on production. So there's some hysteresis in the system. Uh, because the prices have dropped, our production is going to start to drop. If it drops too much and then we don't have enough oil and gas, the prices will start to go up again. So we're always trying to get that right balance between the supply side and the demand side.
Great, thanks. Do you think that the workforce issues that we're currently having because of the low price of oil is just domestic, or are there other international places that may be hiring as well? Or is the limitation problem just pretty much equally everywhere?
Yeah, it's pretty much equal everywhere. Um, with the supply capabilities that we have now, the price uh, the price of oil is almost a global commodity. Um, European oil is a little higher in price right now than U.S., but typically prices around the world for a barrel of oil are pretty close to each other. So it's not that the U.S. is suffering, but things are great over in Europe or in the Middle East or in the Far East. This is a worldwide decline in oil prices, and it's impacted every aspect of the energy sector. Geoscience and engineering and the people that work in the refineries and just covers the whole gamut of the workforce.
Thanks. So we're coming up on an hour, and I wanted to know, Fred, if there's any last words of encouragement or anything that you want to just sum everything up with. And
Yeah, there's one thing I forgot to mention that I think it is important. We'll put aside the fact that the price of oil is down and the job market's a little tight, but in general, most companies do their recruiting in the fall, September, October, November. That's when they decide who's going to be a new hire in May, June, July, who's going to be an intern in May, June, and July. And I have seen a lot of grad students and undergrads as well. They're focused on finishing their degree, and then they're within a couple of weeks of finishing, and then they say, "Oh, well, I better start looking for a job." So if there's one thing I could suggest is that you really need to be almost a year ahead of finishing your degree when you're starting to ask yourselves, what type of job do I want? If I want to be in the energy sector, do I want to work for a super major? Do I want to work for a small company? Do I want to work in Houston? Do I not want to work in Houston? And attending job fairs, attending interview meetings, you really need to be doing that 9 to 12 months before you anticipate finishing your degree and being ready to enter the workforce.
Great. Thank you so much, Fred. And for your entire webinar and for answering all of these questions. I think it helps a lot to hear from somebody who's inside the industry. So thank you
Well, I
so
enjoy doing it.
much. Thank you. So that concludes our webinar, and stay tuned. We'll have our next one in just a couple of weeks. So stay tuned for that. Thanks.